Hello to the doctor watching this video. So our group is going to present our project 2 result, and our group is formed from 3 members, which is me, Leonard Suen Kit, and Aaron Tan Yongzhen. So for the introduction, this project explores the statistical analysis of student scores to uncover significant patterns and relationships that impact academic performance. We utilize a range of statistical methods to analyze various factors such as class attendance, participation in extracurricular activities, and self-study habits. Firstly, two sample hypothesis tests are employed to compare the performance of different groups of students, such as those with varying levels of class attendance or extracurricular participation. This helps determine if these factors significantly affect their academic outcome. Next, we use correlation and regression analysis to investigate the relationships between weekly self-study hours and scores in subjects like math, history, physics, chemistry, biology, and English. By understanding these relationships, we can identify key factors that contribute to better academic performance and make informed predictions. Furthermore, the chi-square test of independence is applied to examine the association between categorical variables such as class attendance and extracurricular participation and their impact on student scores. This helps us understand if these activities are linked to better academic results. For the data set, this is the description of our data. The population we get are from students, and the sample we took are 200. So as you can see, the data description, we have 11 variables, which is ID, gender, absent days, extracurricular activities, weekly self-study hours, math score, history score, physics score, chemistry score, biology score, and English score. The type of variable, two kinds exist, which is quantitative and qualitative, and the measurement level for ID is nominal, for gender is nominal, absent days is ratio, extracurricular activities is nominal, weekly self-study hours is ratio, math score, history score, physics score, chemistry score, biology score, and English score, all of them are ratio. For the statistical test analysis, for the two sample hypothesis testing, the selected variables were math score and gender. So the objective is to determine if there is a significant difference in performance based on gender. This analysis will help us understand whether gender plays a role in academic achievement in mathematics. So for this test, the expected outcome is we expect the two sample hypothesis test to determine if there is a statistically significant difference in math scores between male and female students. We anticipate that the test will either confirm or refute the hypothesis that gender affects math performance, potentially revealing any disparities or similarities in scores. As for the correlation analysis, the variables selected were weekly self-study hours and history score. The objective of this analysis is to investigate the relationship between the amount of time students spend on weekly self-study and their performance in history, as measured by their history score. Specifically, we aim to determine if there is a statistically significant correlation between weekly self-study hours and history scores, and to understand the nature and strength of this relationship. The expected outcome is we anticipate that the correlation test will reveal a positive and significant relationship between weekly self-study hours and history scores. This means that as students spend more time on self-study each week, their history scores are expected to improve. The findings are likely to indicate that increased self-study is associated with better performance in history, offering insight that could guide effective study practices. For our regression analysis, we use weekly self-study hours and math score as our variable. The objective of this study is to use regression analysis to examine the relationship between weekly self-study hours and student math score. We aim to determine the extent to which weekly self-study hours predict math performance and to quantify the impact of self-study on math scores. The expected outcome from this analysis is to reveal a positive and significant relationship between weekly self-study hours and math scores. Each additional hour of self-study per week is anticipated to lead to higher math score, indicating that increased self-study contributes to better math performance. The findings are expected to provide valuable insights for improving educational practices to enhance student success in mathematics. As for the last test, which is chi-square test of independence, we use gender and extracurricular activities as our variable. We want to examine the association between gender and participation in extracurricular activities among students using the chi-square test of independence. By analyzing these categorical variables, we aim to determine if there is a significant relationship between a student gender and their likelihood of participating in extracurricular activities. So, from this test, the expected outcome is to review whether there is statistically significant association between gender and participation in extracurricular activities. If significant, the result may indicate that gender influences the likelihood of participating in extracurricular activities, highlighting potential differences in interests or opportunities.
Okay, for this part, I will be explaining the hypothesis test and the correlation test. For hypothesis test, in this analysis, we will be using the variables of math scores and gender, where we will be testing whether the mean math score of female students is different from mean math score of male students. From the data, the frequency is n, the mean is x bar, and standard deviation is s. Using the CBS file we put into our studio, we have 103 female students and 97 male students, because our total is 200 students. The mean of female students is 84.47, and the mean for mean math score for male students is 83.14. The standard deviation is for female students is 11.18, and the standard deviation for male students is 15.07. The hypothesis statement is there is no significant difference between gender and math scores, and the alternative hypothesis is there is significant difference between the gender and math scores. We found after that we used the statistic where we found 0.705, and using that we calculated. After that we calculated the degree of freedom using this formula in our studio, and we got 176.6429, and we rounded that up to 176, where we got the negative critical value, which is negative 1.96, and the positive, which is 1.96. Here is the two-tail test for the this hypothesis. The negative 1.96 is here, and 1.96 is here, where our t value 0.705 lands here in the middle of the graph, which means that we fail to reject the null hypothesis, since hence there is significant evidence to conclude that the mean math score for female students is the same as the mean math score for the male students. After that, I will be explaining this correlation test. In this analysis, we will be using variables of weekly self-study hours and history score, where we will be testing whether the value of history score depends on the value of weekly self-study hours. You'll be using weekly self-study hours as the independent x variable and the history score as the dependent y variable. Here is a graph that we got for this data, and according to this scatter plot above, there is a weak positive correlation between weekly self-study week hours and history score. The relationship, in fact, is the more time spent in self-study, the higher the score will be. However, there's few outliers above this as well. The degree of freedom, the degree freedom formula is n minus 20 minus 2. Here is the Pearson product moment correlation coefficient. We'll be using this formula to find out the R value, where all this is gotten from the RStudio, where R is 0.035. After that, we will be finding out the significant test for correlation. The hypothesis test, hypothesis statement is P equals to 0, means there's no linear correlation. P does not equal to 0, means that linear correlation exists. Using this formula, we find out with the R value what the T statistic is, where we got 0.488 basically, and from that we will get since this is a two-tailed test, there are two critical values where we found it, and is negative 1.96 and 1.96. In conclusion, because the 0.488 is in the middle of 1.96 and negative 1.96, we fail to reject this null hypothesis, and there's no sufficient evidence to conclude there is a linear relationship between weekly study hours and history scores at alpha 0.05. That's all for my part. Thank you.
Good morning, Doctor. Today I will be presenting the regression test analysis from our project on the statistical analysis of student scores. So in this analysis, we will be using variable weekly self-study hours and math score, where we will test whether the value of math score depends on the value of weekly self-study hours. Using weekly self-study hours as the independent variable and math score as the dependent variable y. Our regression model is a linear model, hence simple linear regression is used. The changes in the value of math score are assumed to be caused by the changes in the values of weekly self-study hours. And this is the scatter plot without regression line. Okay. So now, for this analysis, we use a simple linear regression model where this formula, the dependent variable y is the math score and the independent variable x is the weekly self-study hours. The population intercept, the population slope coefficient, and random error term. Okay, so we assume the following condition for our regression model. The error values are statistically independent and normally distributed for any x. The probability distribution of errors has a constant variance, and the underlying relationship between the independent variable weekly self-study hours and the dependent variable math score is linear. First, estimated regression model. From the equation above, B0 is estimated average value of y math score when the value of x weekly self-study hours is 0, also known as y-intercept, whereas B1 is the estimated change in the average value of y math score due to a 1 unit change in x weekly self-study hours. Okay, using RStudio, we get that B0 equals to 77.08174 and B1 equals to 0.38565696. So substitute the values of B0 and B1 into the regression model equation. The estimated y value for observation I equals to 77.081 plus 0.3x6x. From the equation, we can interact the data of intersection coefficient B0 and slope coefficient B1. In the data, B0 equals to 77.081 01 and 08174 indicates that for students within the range of weekly self-study hours observed, 77.08174 is the portion of math score not explained by weekly self-study hours, whereas B1 equals to 0.856596 indicates that the average value of math score increases by 0.38565696 on average for each additional 1 unit of weekly self-study hours. Okay, the next step is explain and unexplained variation. So using RStudio, we get that SSE equals to 30,400, SSR equals to 4,217.178, and SST equals to 34,640.88. And next is the coefficient of determination R2, and using RStudio, the coefficient of determination was calculated to be 0.1217. Approximately 12.17% of the variation in math scores is explained by the variation in weekly self-study hours. Next is standard deviation of regression slope, and this is the formula of standard deviation of regression slope. Using RStudio, we get that estimate of standard error of the least square slope equals to 0.073611504. Inference about the slope t-test. The null hypothesis H0 is beta 1 equals to 0, and alternative hypothesis H1 is beta 1 and not equal to 0, and linear relationship does exist. The next step is find the critical values. So using alpha equals to 0.05 and df equals to 198, we get the critical values is 1.96 and negative 1.96. Hence we reject null hypothesis H0 if test statistic is smaller than negative 1.90 or test statistics greater than 1.96. Next, calculate test statistic. Okay, and from the RStudio we get that t equals to 5.2389, and this is the decision chart. Since 5.2389 greater than 1.96, we reject the null hypothesis. There is sufficient evidence to prove that weekly self-study hours are correlated to math scores at alpha equals to 0.05. And this is the linear regression model. And next, to perform linear regression in R, we use the LM function. So from the image above, we can see the value of intersection coefficient intercept and slope coefficient x. And this shows the summary of the value we calculated. Okay. Finally, we can add the linear regression model into the scatter plot, and this is the scatter plot with the regression line.
So right now, I am going to explain about the chi-square test of independence in this project. So in this analysis, we assess the independence of two variables, which is extracurricular activities and gender, using a two-way contingency table. Test of independence at 95% level. We employ the chi-square test of independence with a two-way contingency table. So as you can see in the figure 3.4.1, that is the frequency of gender participating in extracurricular activities. For female, there are only 18 out of them who participate in extracurricular activities, while 85 of them didn't participate in extracurricular activities, while for the male, 26 participate in extracurricular activities, and 71 didn't participate in extracurricular activities. So, firstly, we have to state the hypothesis. For our null hypothesis, it is extracurricular activities is independent of gender, and for our another hypothesis, extracurricular activities is not independent of gender. So right now, we have to find the critical value. Since we are using 95% confidence level, so our A alpha will be 0.05, and right now we have to find the degree of freedom. So finding our degree of freedom, we have female and male, and false and true. So we are going to execute 2 minus 1 times 2 minus 1, and we will get 2 equals to 1. So if we refer to the chi-square table, the critical value is equals to 3.8415. So in the figure 3.4.3, that is the expected count calculation. And for figure 3.4.4, test statistic value calculation manually. This is the result of it. And the test statistic value we get are 2.5332. So if we use RStudio, getting the test statistic value is the same as the manual calculation. So for the conclusion, since the test statistic value equals to 2.5332 is smaller than our critical value, it didn't fall into the critical region. Thus, at the 95% confidence level, we fail to reject the null hypothesis and conclude that there is no significant association between gender and participation in extracurricular activities.
Okay, conclusion for our two sample hypothesis test. We investigated whether the mean math score of male and female students differ, assuming equal variances. Our analysis revealed no significant difference in mean math score between male and female students, leading us to fail to reject the null hypothesis. This suggests that gender does not play a significant role in the determining academic performance in mathematics among the students in our sample. In our correlation test, we examine the relationship between weekly self-study hours and history scores. The results show a positive linear correlation R equals to 0.3464, prompting us to fail to reject the null hypothesis. This indicates that an increase in weekly self-study hours is associated with higher history scores, suggesting that self-study habits significantly contribute to better academic performance in history. The regression test focused on the relationship between weekly self-study hours and math score. Our linear regression model indicated a positive linear relationship, leading us to reject the null hypothesis. This implies that an increase in weekly self-study hours is associated with an increase in math scores, corroborating the notion that consistent self-studying can enhance academic performance. Lastly, our chi-square test of independence assesses the relationship between gender and participation in extracurricular activities. The analysis revealed no significant association, leading us to fail to reject the null hypothesis. This indicates the gender does not significantly influence the likelihood of participating in extracurricular activities among the students in our sample. In summary, our findings suggest that while gender does not significantly impact math score or extracurricular participation, weekly self-study hours positively correlate with better history scores. This project, utilizing statistical tests such as two-sample hypothesis testing, correlation analysis, regression analysis, and chi-square test of independence, has effectively enhanced our data analysis skill. Special thanks to our lecturer, Dr. Izyan Izzati, for her guidance throughout this project. And this is our appendix from Mark Medak Comprehensive Student Scores Dataset retrieved from the link. Okay, that's all. Thank you.